Let's look at a limit proof of the product rule for derivatives. So the product rule states that if you're taking the derivative of f of x times g of x, that's the derivative of f times g plus the derivative of g times f. It kind of has that crisscross action to it. So we're looking at the derivative with respect to x of this f of x times g of x function. And the limit definition says take this function at x plus h, f of x plus h, g of x plus h, subtract the function at x, f of x, g of x, divided by h. Now, I can see some crisscross f and g action going on, but I don't see a sort of f of x with a g of x plus h. I only have x plus h, and x together. So I'm going to see what happens if I actually make this worse before I make it better. F of x plus h times g of x plus h. And I'm going to be adding, I'm going to start by subtracting. Oh, it doesn't matter either way. F of x times g of x plus h and minus that same thing. So technically this would cancel out if I wanted it to cancel out, but I'm trying to get that cross action that I see in the final answer derivative. And in part, the reason why I'm doing this is I'm wondering if I had four terms, if I could factor this by grouping, and all this is over h. So for example, these first two things, it looks like they share a g of x plus h. These second two things looks like they share an f of x. So I can really mix this up however I like. But let's try pairing this g of x plus h piece up with this other g of x plus h piece, because then I have x plus h minus x. So let's see what that looks like. So I'll have f of x plus h times g of x plus h minus f of x times g of x plus h. Okay, and I'm just going to sort of put clumps around that. That was my first checkmark group. And I have a little bit of cross action now, so that's good. I can see the F's and the G's with sort of different letter combinations. I also have, I'll do this with little squiggles here, f of x, g of x plus h, minus f of x, g of x. And this entire thing is over h. Okay, let's look at, so I have my same 1, 2, 3, 4 terms here. I'm just remixing them. Let's look at that first set. I have the limit as h goes to 0. They share this x plus h. So I'm going to send that to the front for this piece. So I have g of x plus h, and that was multiplied by f of x plus h minus f of x all over h. I'm also going to look at the limit as h goes to 0 of the second piece, also over h. Here we had f of x shared for both of those terms, so we can factor out an f of x. What remains is g of x plus h minus g of x. Now I'm going to highlight some pieces here. In particular, if I'm looking at that f of x plus h minus f of x all over h, that's the derivative with respect to f. Likewise, if I look at the second piece, I have g of x plus h minus g of x over h, and that is the derivative of g. Let's see the other pieces that are left for each of these. So for the first one, the thing that I haven't touched is that g of x plus h, but h is going to 0. So I have g of x plus 0. F of x doesn't have an h at all. That's just f of x. That can drop down. X plus 0 is just x. So I have g of x, f prime of x, plus f of x, g prime of x. So that establishes the product rule for derivatives with that cross action. Again, the trick to really make this happen is to make it worse, at least just for the start, where you're introducing some sort of f of x with g of x plus h. Since I added and subtracted that same value, technically those things cancel out. So I haven't changed any of the numbers, but it does allow me to get a bit more creative when it comes to grouping terms together. So I hope that helps. That's the proof for the product rule for derivatives.